So we're going to add these two exponents. So 4 squared, which is 4 times 4, is going to be 16. And then 2 to the 4th, which is 2 times 2 times 2 times 2, that is also 16, and we get 32. Next one is 2 cubed, which is 2 times 2 times 2, which is 8, and 3 times 3, which is 9, and that gives us 17. So just so you are aware, for example, the 4 squared, this will never be 8. Okay, that does not equal 2 sign. You don't just multiply the big number by the small number. This is called the base, and this is called the exponent. So the exponent tells the base how many times to multiply itself by. So 4 squared is going to be 4 times 4, which is the 16. Again, so 2, you see that it's written twice. That's where the 2 comes from. And then the item that gets written twice is the base. So that's where that comes from. Just really quickly, for the 2 cubed down here, that's going to be 2 times 2 times 2, which is 8. Okay, try these examples on your own. So this one is 3 squared, which is 9, 2 to the 4th, which is 16, and that is 25. Next one, 2 squared is 4, 2 cubed is 8, and 3 squared is 9. 4 minus 8 is -4. -4 plus 9 is 5. And from here to here, I use the order of operations. When you do adding and subtracting, it's from left to right. So that's why I did 4 minus 8 first. Do not add 8 and 9 together first. Not allowed to. Okay, so most students mess this up because negative signs are introduced. So before I do this first example, I want to go over what's the difference when there's a negative with or without a parentheses. So let's take this example. I'm going to do this on the right here. -2 squared versus -2 squared. Ironically, you say it the same way. Some teachers will say the quantity -2 squared to help you know that there's a parentheses there. So when the negative, I'm going to do this first, this example right here first. So when there's a negative sign, you just bring the negative down and then perform the exponent work and keep bringing down the negative and get -4. In this example right here, we're going to write -2 times -2, which is +4. So the whole trick here is what is the base and what is not. This negative sign is not part of the base. And so that's why I didn't do -2 times -2 for this first example. However, this next example, this -2 here is the base because it's trapped in the parentheses. And so that's why I wrote -2 twice, because it's part of the base. So hopefully that clarifies things for you when you're dealing with things that have a sign or not. Okay, so moving on to our first example, the negative is going to stay the same. 5 squared is 25. And then -4 times -4 is 16, so that's 16, 16. So I'm going to have to find a common denominator, put this over 1. So this will be 48. And so then the final answer would be 23/3. Okay, moving on to the next example. The next one, I have 3 over -2 squared is going to be 4, plus -2 times -2 is +4. I'm going to have to find a common denominator again, excuse me. Common denominator is 4, and that's going to be 16. So I'll have 13/4 as my final answer. Okay, so the numerator is going to stay negative. 2 squared is 4. Denominator, -3 times -3 is +9, and that is my final answer. Just so you're aware, you can write -4/9 in 3 ways, and they all mean the same thing. So these are the 3 ways that you can write it. The ones that I'm putting a check mark under are the ones that are the most popular way to write your answer, but all 3 are fine. Okay, so the next one, I have negative half times a negative half, and that's going to be 1/4. And then minus 3 squared, which is 9. And then I'm going to do 9 over 1, common denominator is 136, negative 35 over 4. Just so you're aware, you might need to do some side work. Some of you may not know off the top of your head that negative 1/2 times negative 1/2 is 1/4. So I encourage you to do that off to the side. You know that negatives and negative is positive. Nothing reduces, so that's going to be 1/4. There will be some problems in your homework that I want to see the work for, so your best bet is to just show me all your work so I can give you full credit. Okay, the next lesson, you have to perform the operation inside the parentheses first. So this one is going to be 3 plus 2, which is 5. I'm going to carry the exponent over, and then the denominator, 2 times 5 is 10. Carry the exponent, which is 3. Now I'm going to simplify the numerator as 25, because 5 squared is 25, and the denominator is 1,000. So for this one, it goes into evenly by 25. Some people don't think of 25 going into 1,000, so what you can do is reduce by 5 first and get 5 over 200, and then that's going to be 1 over 40. But that's up to you. I go right into 1 over 40, but if you want to reduce little by little, that's okay. Okay, so the next one is going to be 6 squared over 3 cubed. 2 times 3 is 6. 2 plus 1 is 3. 6 squared is 36, and 3 cubed is 27. I'm going to reduce by 9 and get 4/3. Okay, the next thing is the numerator. 2 plus 5 is 7, so 7 squared. 2 times 3 is 6, 6 cubed. 7 squared is 49. I don't know what 6 cubed is, so I have to show my work here. So that's going to be 36 times 6, and 36, kind of messy, 216. And that's my final answer. Okay, the next example, 2 times 3 is 6, 6 times 4 is 24, 24 squared. 2 plus 3 is 5, 5 plus 4 is 9, so that's 9 squared. So I have 24 squared. So I have to do the work here, obviously. $576 over 81. I'm going to reduce by 9. I'm going to show that this is divisible by 9. And so this is going to be 64 over 9, which is my final answer. Just a quick note that there is a little trick here for this step right. Oops, that's definitely not what I wanted to do. I want to highlight that. So you could, at that step, you could change it to this. 24 over 9 squared, and reduce the parentheses first by 3. And then do 8/3 times 8/3, which is still 64 over 9. I noticed I didn't do that trick in this first example. The reason is because the two exponents are different. And I couldn't even reduce 7 over 6 even if I wanted to. So the trick here is, just to reiterate, is that if the exponents are the same, then you can put the bases in a single fraction and reduce that fraction to make your life a little bit easier. So there's multiple ways to do that. I obviously prefer this way. Just as a general overall note, as you know, you need to show all work for your credit for the problems. So work like this is absolutely necessary when you're doing your homework, or else I'm going to think you used a calculator. And then the work here, if you decided to do it that way, I definitely need to see work for larger numbers like that.